Our project is on detect and analyze of cracks in surface machineries. Actually, you know that machines play a key role in industries in order to perform a specific task. But in industries, machines are facing a certain problems is due to failure of the machines. Actually, we can't identify the exact problem of failure in a machine. Mainly, it occurs due to cracks in a machine. Some of the causes for these cracks are losses of usefulness. Mainly, it causes obsolescence, surface degradation, and accidents. In surface degradation, 70% of the cracks are in industries machines. This surface degradation are classified into collision and mechanical wear. This mechanical wear contains 50% of the cracks. This mechanical wear is classified into three types: abrasion, fatigue, adhesion. This made us to come out with an innovative idea of using specific features such as Microsoft HD Cam 5000, Stereo Vision camera or NI Smart camera. This is the Microsoft HD 5000 and it is stereo vision camera. This is the main block diagram of our implementation. You choose LabView to implement or experiment since it is a graphical user interface and made a programming work simpler. This is the main V.SAI of our implementation. Already I showed the block diagram of our project. It contains of 9 blocks. In this, it is formed by the combination of 9 blocks. Let us see the real-time implementation in the front panel. This is the front panel where the file path which plays a key role in order to capture an image. You can use the camera which has high resolution. I used NI Smart Camera. By using NI Smart Camera, I took a cracked image of a wall. This is the cracked image of a wall. You can take an image or cracked image by using Microsoft HD Cam 5000 on Stereo Vision. I took the image and inserted in the file path. Now let us execute this. Now I am running the program. As soon as I run the program, it's giving the signal to noise ratio value, mean and standard deviation. It represents the threshold. XY value is the nothing but pixels variations. We have 3 pages. In page 1, we have original, denoise image, reconstructed image. Denoise image is nothing but it is used to remove the additive noise. We have different types of pixel values and the original image can have the wavelength in the form of decibels. And these 4 images represents to the undecimated wavelet transform. We have low high and high. It have different types of representation such as vertical, horizontal or diagonal. It has the same pixels values. It varies with the low high and high. You have the histogram in which shows the number of pixels in an image at each different intensity value found in that cracked image. It has 255. Totally it has 256 from 0 to 255. Now let us see the page number 2. What will happen in page 2? In page 2, you have enhanced image and threshold image. The threshold image used to convert grayscale image to binary scale format. It has the threshold value of minimum value and maximum value. The minimum value always starts with 0. The maximum value depends upon the particle of pixels. Let us see the 3D graph of pixel value of the cracked image. This is the 3D graph in which it shows depending upon the cracks. This is the position of the crack. Let us see clearly in this format. This is the position of the crack in which I took by using a camera. This is the crack position. And you see in the form of wave. The grayscale which has the intensity depending upon the frequency and amplitude. This gray format will have Gray in color. This cracks represent in the grey in color. This is the waveform graph. And you already explained about histogram enhanced and enhanced image. Let us see in what will happen in phase 3. In phase 3 we have reconstructed image and the original image, and how the original image and reconstructed image are represented in 2D SFT, I mean discrete fast Fourier transform. In reconstructed image, the cracked image is shown in the form of inverse direction. Now we will give a brief explanation of each block.
According to our implementation, image acquisition is the first stage. It is the creation of an digital image, typically from a physical scene. After the image has been obtained, various methods of processing can be applied to the image to perform the many different vision tasks required today. It is the front panel of an image acquisition which is obtained by using vision acquisition. Stage is pixel value calculation. It is a single point in a graphical image. Graphics monitors display features by dividing the display screen into thousands of pixels arranged in rows and columns. The number of bits used to represent each pixel determines how many color shades of gray can be displayed. It is the finding of cracks. It will display the detection in rows and columns. The next stage is histogram. It is a graph showing the number of pixels in an image at each different intensity value found in that image. For an 8-bit grayscale image, there are 256 different possible intensities, and so the histogram will graphically display 256 numbers showing the distribution of pixels. The next stage is thresholding. Thresholding in an image processing is used to convert grayscale image to binary format where two possible values are 0 or 1. Thresholding is common step in an image analysis where you need to differentiate pixel area by two different brightness areas. For example, between the objects and the background. An object pixel is given a value of 0 is denoising. In this, an image denoising is used to remove additive noise while retaining as much as possible the important signal features while preserving edges. One common approach is to use Gaussian filter. Firstly, it applies the wavelet transform to the noise data and obtain detailed coefficients and approximation coefficients. The next stage is edge detection. It is the most important stage in an crack detection. It is useful for locating and extracting information about areas of strong intensity constraints. In many applications, it is necessary to find boundaries of objects that appear in images. Edges can be detected with the help of gradient or derivative operators. The front panel explains about the thresholding rules and rescaling method. Stage is line profile. It is similar to edge detection. In line profile, you consider line along the boundary of the image and you calculate the pixel values along the line of original image and cracked image. Angle of inclination of the crack can be calculated, finding the difference of minimum and maximum values plotted in the gradient information. In this front panel, the above graph represents the line profile and the below graph represents the cracks as in the form of gradient information. Undecimated wavelet transform, the images are separated into four images. In the first level, namely low low, low high, high low, and high high, by using discrete wavelet transform. The level 1 of discrete wavelet transform results for the uncracked and cracked images. The level 2 represents the low low, low high, high low, and high high without crack and with crack. Thus, our project stands unique from others. On the whole, this system would be a great chance for the industries in identifying the cracks and to overcome failures of missions.